Alright, hi everyone. This is the 13th session. So today, until yesterday, we talked about probability, and there is a reason why we talked about probability because it serves, as I mentioned before, as a basis of statistics, and we'll see how that is the case. Right. So what we're going to do today is called probability distribution, and this is basically what we did yesterday, but building some stuff on the top. So let's just get started. Alright, so this is alright, so this is a probability distribution. And before we define anything, or if before looking into the definitions, let's just take an example. Alright, so let's say we're we're tossing a coin, and let's do this, let's see, 3 times. Okay, let's define some sample space. Sample space would be what? H H H H H T H T H. Okay, so there should be 8 in total. Okay, so this is 1, 2, 3, 4, 5, 6, 7, and 8. Right? Alright, so these are the sample spaces. And say that we are looking at, what we're looking at is the number of heads. Okay, so this is what we're looking at. And let's define this as x. So x equals the number of heads. So how many possibilities are there for x? Well, x can be 0 if everything is tail, right? X can be 1, 2, and 3. Okay, so if we were to make a little, I guess, chart, it'll look something like this. So if x equals 0, this is what? T, T, T. All tails, right? If x equals 1, then it's going to be H, T, 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 H, T, and T, T, H. So there are 3 cases. So here there are 1, there are 3. If x equals 2, this is H, H, T, T, H, H, or H, T, H. Oops. So there are, again, 3 cases. And if x equals x equals 3, oops, then it's going to be H, H, H. Okay, so we call this distribution, where we're looking at an event, and there are numerical values assigned to those events, right? And we're going to define something called random variable. Right? So random variable say x, this associates a numerical value with each outcome of an experiment. Okay, so as we did before, for assigning x as a random variable, then we assign a certain value, right? And we pretty much count how many times it occurs. And this is, I mean, this happens because this is a discrete case. Discrete meaning this is countable, like x can be 0, 1, 2, 3, but there is also another case where it's continuous. And most of the time, continuous happens a lot often, and this is more, I guess, more prevalent in the daily life, because, for example, if you're looking at time, it's a continuum. It's not a discrete value where we're looking at 7 o'clock or 8 o'clock or anything. What else is there? If we're looking at weight or height, all those values are all continuous. So to be fair, I would say that discrete cases are one of the more special cases. Okay, so those are what we define as random variables, and the set of values that x can take. So sample space for x is called the range space. So that's just the term that we use. Okay. All right. So just going back to this example. Right. So we already established that for sample space we have how many in total? This is 2 cubes, so this is 8 in total, right? And these are the values that we take for x. Okay, so 1, right? And when we're looking at probability, again, I said that this is a probability distribution. If we're looking at probability, then we would have to do something like this. If we're looking at probability that x equals 0, then it's going to be 1 over 8, because the sample space is 8. There are 8 possible ways of for sample space, right? Same thing. So if x equals 1, then this is going to be 3 over 8. If x equals 2, then this is going to be 3 over 8. And if it's 3, this is going to be 1 over 8. So we call this probability distribution. So when we're talking about a distribution, we're talking about essentially how many cases are there, like how is it likely to happen. So we're saying that getting a 0 head is 1/8 of a chance, and getting 1 head is 3/8 of a chance. So these are called probability distribution. Okay, and if you remember, it looks kind of like relative frequency, and it is. It is the case because when we're looking at probability, we're essentially looking at the frequency, and later we're gonna define that as PDF, probability distribution function, and that correlates with the topic that we learned, relative frequency. So it is frequency because we are counting how many times it occurs. Right, so let's look at another example. Okay. So we talked about probability. Oh, before we go on to that, let's I do want to mention some properties of probability distribution function. So we call that probability distribution. Okay. For this is for discrete case. Okay. We denote this as f of x I, because there are I different cases for I, right? And this is going to be probability of the random variable x, and random variable is denoted by big capital X equals small I, right? And this has following properties. First is that this is greater than or equals to 0, or less than or equal to 1 for each value of xi, right? And the second case is that if we add up all the cases, then we are bound to get 1, because that is what probability stands for. Okay, so if you're adding all the numbers, then it would be 1. So these are, I guess, the basic basic properties that we are already aware of. Okay, so let's now look at an example. So this is frequency distribution for magazine subscription. Okay, and we denote the number of magazine subscribed by x. This is a random variable, and this is frequency and relative frequency. This is similar to what we've done in the past. Right, so there are 5 options for x, and these are the frequencies. And these are the relative frequencies. Okay, and if we were to add these up, you would get 401, of course. Okay, so we're looking at this, and alright, so one thing to note is that although these are very similar, if you're looking at frequency, okay, so frequency and probability distribution, these are very similar. These two are, I would say, when people say something like frequency and probability distribution, they're almost interchangeable. However, there is a difference between these two that's worth noticing. That is that frequency is based on sample, right? Frequency itself, we're never talking about population. We're talking about frequency, because that's what we are talking about. We just collected a sample, and we're just analyzing them. Whereas probability distribution function is always going back to the population. It is true that we are basing off of a sample, but it is always talking about the population rather than just samples, right? So for random variable x, if we were to find, where is it? Okay. So if we were to find this, say the probability of x is less than or equal to 2, then you would have to add all the values less than 2. So this would be x equals 0 plus probability of x equals 1 plus probability of x equals 2. So that would be 15.38 plus, plus, that should be a plus. I don't know why it's doing this again. So 15 plus 38. Yes, there we go. Plus 27.27. Where is my pen? Okay, it's right here. 27. If you add these up, what do you get? 30. 0.7? Is that right? Or 8? Is it 8? Yeah. That should be 8. Okay, so let's just fix this. So this is pretty much when we're talking about these type of probabilities. Okay. So what I'm gonna do is let's see. Yeah, I will give you two examples, and I want you to work on them by yourself. And let's come back to it. And these are very, very easy. You know what? I'll just give you one example to work on, and we can figure this out, right? So okay, so here's an example that I want you to work on. So for each case, list the values of f of x and examine if the specification represents a probability distribution function, right? If it does not state what properties are violated. So for A, B, C, and D, you're given a probability function distribution function. So you're supposed to analyze it if it makes sense, or if it doesn't make sense, you have to explain why it doesn't make sense, right? So work on that and pause the video, work on that, and once you're done, you can come back to it. Okay. So so let's do this now. For part A, these are very easy because you're given random variable x in the function and you're supposed to plug in values for these. So it gives you 1, 2, 3, and 4. So what you do is you just plug it in. So say for f of 1, f equals 1, then it's going to be 0. So this is 0, not a 6. That's a 0, right? F of 2 is 1/6. F of 3 is 1/3, or let's just write it this way. And f of 4 is 3/6. Right? So if we add them up, you um, sum of all fxi's is 1. So it is a probability density function, right? So this is what you are supposed to do. Just add up the values and see if each of the functions are greater than or equal to 0 and less than or equal to 1. And if that makes sense, and if you add them up to get a 1, right, then it is right. Right? So it's same for the rest of them. And I won't spend time going over these because I think these are easy. And let's just go over part D because I think that's something that I want to go over. So for f of 1, no, f of 0, this is just 8 over 15. F of 1 is 8 over 15 times 1/2. F of 2 equals 8 over 15 times 1/4. F of 3 is 8 over 15 times 1/8. So this comes out to be 1/15. This comes out to be 2/15. Comes out to be 4/15. And this is 8/15. And does that add up to 1? Yes, it does. So this is, in fact, a probability function. Probability distribution function. See? So, let's move on. And let's discuss mean and standard deviation. So we saw from previous examples that it is a function. Probability distribution has a function, right, and has observations, as we did see for frequency table. So it does have mean and standard deviation. So we are going to standard deviation. Going to look into it, looking at frequency distribution, if how we can come up with these measures. Alright, and it's the same. So for mean, we always use you know what, let's take an example and see. Yes, let's just take an example. Alright, so I'm going to copy this over. What should we work on? Yes, why don't we just work on this? Alright, so I'm going to copy this part over. And so just Alright, so this is the stuff that we worked on before. Alright, so oops, sorry. And again, x represents a random variable. This is number of heads. Okay? So if you were looking at mean and standard deviation, right? Then we would have to get this from, so x bar, we're trying to find x bar, which is the mean. Right? Then we would have to multiply the number, the x, and the frequency. right? So it's going to look something like this. We're going to sum everything up with x and f of x, which is the probability. Okay, so doing that, we get, so it's going to be 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 and 3 times 1/8. Right? So if you do that, what do we get? It's going to be 3, 6, 12 over 8. Right? So this is our, or better yet, 1/2. This is our mean. Okay? So whenever we're looking for mean, we're doing this. We are multiplying the x value with the probability. Alright? And if I'm not sure if you remember the formula for variance and standard deviation, but if we were to multiply it out, and if we look at the formula by itself, it looks like this. Variance, or just write it down as s squared, is summation of x squared frequency minus x bar squared. Okay, and we call this no, never mind. Something to note is that if when we are talking about x bar, or the mean, we call this expected value. Okay, what I mean by expected value is that in average, we are expected to get this value when we are looking at this probability function. So I mean, it's not it's misleading, because you're never gonna get 1.5. It's not possible, because it's either 0, 1, 2, or 3, and there is no value for 1.5. However, we thinking about the probability, on average, the expected value for this function, or the mean, is 1.5. Okay, so that's how we define this. All right, so looking at variance again, it's always let me just write this down again. So expected value, we noted as this. Okay, expected value of x. And variance, I know it might be a little confusing, but this is expected value of x squared minus expected value squared. Right? What I mean by this is the following. So when we're looking at just the expected value, which is the mean, we're just multiplying x and the probability, right? But in this case, when we're looking at the variance, we square the x value and multiply that by probability function. Okay? And that corresponds to this part, which is the expected value square part, and then we subtract that. We subtract the expected value square. So let's just look at this example and see. And I'm sure it's going to make more sense when we're looking at an example. Right? So okay. So looking at this, where is mine? Okay, it's right here. We are looking at expected, so let's just look at the expected value squared, since we found expected value already, right? We're summing up x squared and multiplying by the frequency, so which is x squared, so 0 squared times 1/8 plus 1 squared times 3/8 plus 2 squared times 3/8 plus 3 squared times 1/8. Okay? And if you add these up, where's my pen? These up, you will get 24/8, which is 3. Okay? And that's not it, because we have to do this part now. So we found expected value of x squared. So we call this, to let you know, we call this the second moment. Okay? And of course, expected value, just ex, will be the first moment. Anyways, that's not that important. To find the variance, we do second moment minus first moment squared. So the second moment was 3, and we already found out that the first moment, or the expected value, is 1.5. So you square that, and what do you get? You get 3 minus 0.25, so that's 0.75. Okay, 0.75. So this is your variance. Right? So that's pretty much how you find expected value and the variance. And of course, if you're looking for the standard deviation, you would just take the square root, positive square root of the variance. So that is how you look for your variance and mean, or the expected value, right? So that's I think that's it for the variance and mean part, and I can give you some questions to work on. And this topic goes on forever. What I mean by forever is there are a lot of different distributions. We have something called binomial, geometrical, what else? And normal, exponential, and there are tons and tons of distribution, but unfortunately we don't have time for that. Those are very interesting, and it's really good to look into, but pretty much we are going to skip to the most important distribution, because if you took anything related to statistics, that's something that you have to know, and that's called the normal distribution, right? So after doing some practice on this, because we need to find the probability density function in these basic measures such as mean and variance. So we will do that for simpler things, but we won't have any we won't have much time to do the other stuff. So so for now, I will give you a few examples. I'm just going to type it up right now, and you can work on those. So let's do that. Okay, so I included the questions in the class activity worksheet, so please work on those. There are 5 questions in total. Pause the video, work on those, and once you're done, come back to it and we will go over it together. Alright? So please do that. Okay, so we will go over the class activity questions now. And this is the first question. So, a pantry has 4 cans of tuna, 3 cans of chicken. And the cans are of identical size and the labels can be unglued. 3 cans are picked for dinner at random. Let x equal the number of tuna cans selected, right? And you were supposed to find the probability distribution of x. Alright, so let's do that now. x equals the number of tuna cans. Okay, so x number of tuna cans, and let's look at some the possible cases for x. So x can be, so this is x, and let's say this is p x equals x, right? So there it can be 0, 1, 2, 3. Oh, yeah, 3, because the maximum number is 3 for this case. 3 cans are picked. So what's the probability of getting 0 cans of tuna? Well, we have to look at the sample size first. So sample size, in total we have 7 cans, and we're just picking out 3. So that's going to be 7 choose 3. Correct? So you might actually need more space than this. So since we have 0 cans of tuna, that means all of them are chicken. So it's going to be 7 choose 3. Oh, sorry. Not 7 over 3. 7 choose 3. And out of these 3 cans, we have to choose 3. So that's going to be 3 choose 3, which is 1. Right? So that's the case for 0. For 1, what is this? We're choosing, this is a sample size for all of them, but we're choosing 2 chicken and 1 tuna, right? So that's going to be, out of 3 chicken, we're going to choose 2, and out of 4, we're going to choose 1, right? So that's x equals 1, and when x equals 2, this is x, and this is p of x equals little x, 2, again, sample size stays the same. So we're going to have 1 chicken and 2 tuna. So out of 3, we're going to choose 1 chicken, and out of 4, we're going to choose 2 chicken. So this is the case for 2. And lastly, for 3 tuna cans, we're going to choose 3 out of 4 tuna. Okay? So let's just make a simple table right here, because you have to do the calculation now. This is x, and this is p equals x. P of x equals little x. Okay. So it's going to be 0, 1, 2, 3, and if you calculate these out, you're going to get, let me just do it real quick. Okay, so you're going to get, this is going to be 1 out of 35, this is 12 out of 35, this is 18 out of 35, and 4 out of 35. And if you add these up, you're going to get 1. So this is the probability, that's the probability distribution of x. Okay, so moving on. Right, so what is the probability that at least one can of tuna is selected. So this is asking for probability that x is greater than or equal to 1. And this is going to be probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3, right? And if you add them up, what do you get? That's 34 out of 51. Okay? And at most one can. And that this is at most, it's asking for less than or equal to 1. So this is probability of x equals 0 plus probability of x equals 1. So this is 13 out of 35. Okay? And now we're looking at the mean and the standard deviation, right? So why don't we just work on it right here? So to find the mean or the expected value or the mean, we just multiply the random variable by its probability, right? So since the first one is 0, you can skip this. 1 times 12 over 35 plus 2 times 18 over 35 plus 3 times 4 over 35. And if you do the calculation, you're going to get 60 over 35. Okay, so that's what is it? That's the expected value of random variable x, right? And since we have this, we're going to use this to find variance. And again, variance, where's my, so variance is second moment minus expected value, the whole thing squared, right? So now we have to look for the second moment, right? So we're going to do the same. 0 squared is always 0, so we're going to skip that. 1 squared times 12 over 35 plus 2 squared times 18 over 35 plus 3 squared times 4 over 35, and that comes out to be 120 over 35. Okay, and we're not done yet. We have to look for the variance. So to do so, we take this second moment, subtract first moment squared. Okay, so this is variance of x. If you do this, you're going to get, okay, so this is the variance. And since we're looking at the standard deviation, then we would have to take the square root, positive root of this number, and this is about 0.7. Okay, so that's how you find mean and standard deviation. Okay, all right, so let's look at the second example, and this might have been a little challenging, but so I believe it's doable. Okay. So it's a little bigger. Alright, so this is number 2. A trip insurance policy. I can't see the question now. Okay, pays $2,000 the customer in case of a loss due to theft or damage on a 5-day trip. If the risk of such loss is assessed to be 1 in 200, what is the expected cost per customer to cover, and what is the variance? Okay, so let's look at this, and this is very similar to how insurance, how statistics is used in insurance context, and this is exactly the case. So there are 2 cases to consider. So if there is a loss due to theft or damage, then the insurance company, so we're looking at insurance. Okay, just think that we're working at an insurance company. If there is a loss, we pay 2,000 to a customer, right? And if there is no loss, then what? Then we don't do anything. So nothing happens. Okay, so if you were to make this into a variable, then we would have two different cases: when there is a loss and when there isn't any loss. Okay? And we have to, from the context of the question, we have to figure out what the random variable is. So it says, what is expected cost per customer? So here, x, or the random variable, is the cost. Okay? And we have to figure this out in a way that suits the question the best. And in this case, it just simply said expected cost. So expected value or expected cost. So x represents the cost, right? So let's just make a simple table. So let's say this is a payment, x, right? And we also have the probability, f of x or p of x, whatever you prefer. Okay, so here is the table. So payment, how much do we pay? We have two different cases. So we pay 2,000 in the case of loss. And how often does it occur? It says the risk of such loss is assessed to be 1 in 200. Okay, so 1 in 200 is 1 over 200. So it happens once in 200 cases. So this is going to be 0.005, right? In any other case, so that will be 0.995, there is no payment, 0. Right? So this is the probability distribution function for this case. And now we're looking at the expected value, and expected value, it becomes much easier from here on, because now that we figured out the random variable, you just have to multiply, and it's just a matter of calculation. So let's do expected value. It's going to be 2,000 times 0.005 plus this times that, but that comes out to be 0, so you don't have to write that down. And this is 10. Okay? And since we're looking at variance of x equals second moment expected value of x squared minus expected value squared. Since we have expected value squared, we have to look for the second moment. And this is 2,000 squared times probability, which is 0.005, right? And when we do that, we will get, let's see. So when we do that, we get a pretty big number, which is 20,000. So 20,000. And we're not done yet. So to look for variance, we have to do 20,000 minus expected value squared. So once you do that, you're going to get this number. So this is your variance. Alright? So whenever you have two different cases, then you would have to do the same. You would you will first find the random variable and make a chart to see when it happens and when it doesn't, and what happens, what goes with it, and so on and so forth, right? So this is the second problem on the activity. Let's look at the third one. Okay, so Okay, so a wait person proposed a distribution for the number of meals served on a 2-for-1 deal. Okay, and here is the table, the distribution for the number of meals, and you're supposed to find the mean and standard deviation. And this is pretty simple, right? Alright, so to find the mean, we would have to multiply the variable times the probability. So that's going to be 2 times, okay, sorry, this is supposed to be 0.3. 0.3 plus 4 times 0.5 plus 6 times 0.1 plus 8 times 0.1. Okay, so that's how you get expected value. And if you multiply these out, you're going to get 4. Okay, so this is your expected value. Looking for variance, again, second moment minus first moment squared. Since we have first moment, we're going to look for the second moment, expected value of x squared. That's going to be 2 squared times 0.3 plus 4 squared times 0.5 plus 6 squared plus 0.1 plus 8 squared times 0.1. And if you do the calculation, you will get 19.2. So variance of x is 19.2 minus 4 squared. Therefore, this is 32. And we're not done yet because we are not looking for the variance, right? We're looking for the square root of variance, which is the standard deviation, right? So if you do that, where is my pen? So standard deviation will be square root of 3.2, and that comes out to be 1.79 approximately. Right? So that's the third question. Let's move on to the fourth one. Oops, I'm not sure what happened with this thing. Alright, so for number 4, I'm not going to copy and paste. Just going to see how. Okay, so 12 over 25 for 1, 2, 3, 4. Okay, so for number 4, let me just write this down. Okay, this is number 4. And calculate the mean and standard deviation for this, right? So when we are given some kind of probability function, then we have to make a probability distribution first, right? So this is x, and this is f of x. Okay, so values are given as such: 1, 2, 3, 4. Okay, so when it's 1, it's 12 over 25. When it's 2, it's 6 over 25. 4 over 25. And when it's 4, it's 3 over 25. And if you add these up, you get 1. So it is, in fact, a probability distribution function. Alright, so let's do this. Okay. Alright, so let's do the same thing again. Expected value is going to be 1 times 12 over 25 plus 2 times 6 over 25 plus 3 times 4 over 25 plus 4 times 3 over 25. And if you do the calculation, it comes out to be 1.92. So this is the first moment, or the expected value. So, and to look for variance, we have to find the second moment first. So 12 over 25 plus 2 squared times 6 over 25 plus 3 squared plus 4 over 25 plus 4 squared times 3 over 25, and if you do the calculation, you will get 4.8. And to look for variance of x, you will do 4.8 minus 1.92 squared, and you get 1.11 approximately. And to look for standard deviation, you have to take the square root, right? And you get 1.055. That's your standard deviation and your mean right here. Oops. Okay. And moving on to the last question. Alright. So we're rolling a dice. Okay, so this is the last question. Alright, so it says, let x equal the face showing when a die is rolled, and write the probability distribution function of x and find its mean and standard deviation. Alright, so let's first come up with the probability distribution. Alright, so this is x, and this is probability x equal little x. So obviously you're going to have 1, 2, 3, 4, 5, and 6. This die has 3 sides. And again, the probability will be the same because it's equally likely that you have all of them. So it's 1/6 for all of them. So looking for the mean, standard and mean and standard deviation. So expected value of x is 1/6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? So if you do that, you'll get 3.5 as your expected value. To find variance, you have to find second moment, right? And that's also the same. You just square the value, so 1 plus 4, 9, 16, plus 25, plus 36. Okay? And if you calculate this, you get approximately 15.17. And if you look for the variance of x, this is going to be x squared minus this, right? And it comes out to be 35 over 12, which is about this, right? So that's pretty much it for the probability distribution function, and this is like the basic and base for the for statistics. So I'll give you more questions to work on. I think it's better for you to have more practice. I know this might be a little easy, but I'll try to find some challenging questions for you to think through. So work on those, and I want you to go over those questions in class when you're discussing, and just come up with any problems or any questions that you have. Okay, so I will see you at the Q&A session.